Hey, Michael. Hey, Jen. Hey, Roger. Hey, Rudy.
Hello.
Yes. Hey, Rudy. I can hear you.
Hi, James.
Hey, Michael.
Hey, James, quick question. Where are the recordings located?
Good
Then?
questions. I'm still trying to get that. I think because after they changing to Zoom, so it seems like Zoom they kind of like run all these meeting together with other meetings because we kind of using the same meeting for convenience. We're using the same Zoom link, so we're trying to separate that so that
Okay.
we can. Yeah, we're working and trying to get that. I've been asking for that. Let me get that. Hopefully, I can have that by next meeting. Let me try to push them again.
Okay. Yeah, I was just asking because I know my team has presented a couple of weeks ago. I was on vacation, so I just wanted to catch up on that. So
Yes. Yeah, definitely. I think Chris has been presented. I think in the previous meeting.
Mhm.
Uh, on the spec for the Wi-Fi.
Mhm.
Um, And by the way, there's a slide that he's sharing also. I think I put that in the meeting minutes. You can look into that. But
Yep.
meanwhile, I will get that recording
Yep.
and share with you. And then so you know also like what we have been talked about and discussed
Yeah.
in
Yeah.
that
No,
meeting.
yeah. No, I mean, I saw the slides on the website and I have them internally. I just wanted to like hear what the other comments were. So because I wasn't here. So, anyways, just something. Whenever it's online,
Yeah,
I would like to see it.
that makes sense. That makes sense. I think it just I think it should be there. I think it just we'll work on it and get that to you and to everyone here.
Thank you.
Sure. So there's most people here. By the way, Tony wasn't able to join today. Since he has been traveling. But I've been talked to him briefly. But before that, let me quickly share my screens and then see what we have from the last meeting minutes, and then we can go from there. There's some new content that we discussed with Tony, and then we'll talk about it. Am I sharing my right screen? Let me try to do that again. All right, can you guys see my screen?
Yes.
Yeah, so that's last meeting. I think we talked about the structure, right? So I think we have that spreadsheet that we kind of created based on the components right now. Share that with everyone. I can share with everyone again here. It's just kind of a draft, right? Based on what we have been discussing in previous few meetings. And then we also talk about discussing about the XML versus the YAML and others. So I think Justin and Michael, I think I've been kind of working on some performance. I think comparison on that. So Michael, do you have any update? I don't see Justin here. Do you? Oh, Justin is here. Yeah, Justin, do you have any update on that?
You're talking to me there now, James, is it?
Yeah, to you and Justin. So last time you guys are working on some performance on the processing using the XML, right? Do you have that data you like to share with the team? So
So is Justin, are you here?
Yeah.
All right. So the size of the file that you have at the moment, you're typically in the range of hundreds of lines to represent bump patterns in the scale of billions of bumps.
Yeah, that's correct.
Okay, so is that the type of metric you're looking for, James, are you looking for what other detail are you looking for when we say processing performance?
Yeah, more kind of processing performance. Last time India had been concerned, I say in XML, right, because of the structure-wise processing. I think maybe a bit slower compared to others. I think that's why Austin was saying like.
That was because not of the format. That was because of the number of lines, and what we were looking at is, given the original data structures that we saw, that was provided to us in the samples, for a die that had 18,000 bumps, you had almost 20,000 lines in that file structure. And so when we used that same concept and scaled it to 1 billion bumps, we got file sizes of 38 or 36 gigabytes. Then what we did was we started down a road of doing data architecture, and by reformatting, and you've been at those meetings that we've been working with JEDIC team on over the last number of weeks. As a result of that, we got the same representation of multi-billion bump die that was originally driving 36 gigabyte files. We got that down to just a few hundred kilobytes because of the way that we did the data structure. Now what we're doing is we're creating a sample XML file that is going to have a very complex but yet realistic pattern of bumps projected to be like 10 years in the future in terms of complexity. It will have multi-hierarchical levels of patterns within patterns, scaling up to multi-billion bumps, and we're going to try and have that hopefully ready for discussion tomorrow. So if we have a file format that can now be represented in low, let's say worst case low megabyte size as opposed to gigabyte size, the performance of it is not going to be a problem anymore. Because once you take the format into any software tool, you can expand it inside the tool in binary format to extract the data that you want.
Got it. So do you have that data now that you're able to share with the team?
No, we're putting the final touches to it. I will send you an email. We're asking for some questions that we want to have. We want to make the file as realistic as possible. So the structure of the file is almost ready. We should have it ready by tomorrow's meeting. Okay. But we want to know things like, like project 10 years in the future. What will be the smallest bump size? What will be the smallest pitch size? What's the maximum active area size? So I'm going to send you a set of maybe 10 questions after the meeting. And I'd like you to if you can respond to those 10 questions for us, we will make the XML file reflective of what you send back to me. And then it'll become realistic, and the team here and the JEDIC team can review it and see if they think this is the right way to go.
Okay, yeah. If you have that, yeah, send it, and then you can share with the team here, so we can get a response to that. Back to you on it. Related to performance. Okay. So I talked to Tony, I think in that email discussion that was in between Tony, right? I think I saw you guys have been also in parallel conversation with Intel based on the spec, the wide die spec that they sharing earlier. I think I saw you guys have been already creating some structures for the tire, right? Especially on the tire side, with the existing like part model, right? So
Yeah.
For beneficial of the team, so we're able to maybe share with the teams here. The slide that you have, I think what you like the development that you're sharing there, I think with that, I think that would be good to know. I talked to Tony's and other, I think we I think we acknowledge we're still in process of creating a structure here, but I think it should be aligned with what you guys have there. I think we should be able to kind of adding whatever that new things on top later on. But I think we what you guys have, I think should be a good start, I think, and then we can always look in later down the line to do transformation if we do decide, if the team here does decide, right, want to also support different format and things like that.
Right. So you know the MOU that we signed with JEDEC and OCP. I cannot share the JEDEC documents directly at an OCP forum. If your OCP people want to see that, they need to send me an email, and I'll invite them to the a JEDEC meeting, and then we can present it to them in the JEDEC meeting.
Okay.
When I invite them to that meeting, there's no cost associated with and no need for them to become JEDEC members in order to see the presentation.
I see. Okay. Let's talk about this offline then, how we do that. I think to plug over, I think I just want to share the development that's going on there, which I was attending, to share with everyone. I think I start because in parallel, I think JEDEC has been also a conversation with Intel. I think with the for I think everyone else benefit. I think especially this one, the presentation Chris has been sharing last week, and we said this. So I think what happened is JEDEC, I think in the process of doing that, they also kind of creating the format. I think since the existing part model has already support a lot of this kind of mechanical information there, so they just kind of adding this new rule to existing part model. So including all this kind of the active areas, the physical area, I think die-to-die distance and things like that. So and the bump region definition, those kind of things. So pretty much I think they have that going in parallel, I think, and with discussion, I think with Tony, I think Java and David, I think we thought that since we already in parallel developed with the JEDEC before on the chiplets related to this, and we thought that should be aligned to what we're going to, and then we last time deciding we can support multiple formats. So I think this could be one of the formats that we can support in case there are other formats that are coming out we need to support. We can also be able to align with that. So it's just kind of asking about maybe Jay can share what they have so far, but what I've seen. But I think maybe you can do a different format when they could be another way when they're more ready. I think ready to publish. I think we can share that as well. So, but I think we'll come back on this one day. So maybe I talk to you, Michael. I think after the call and see how we're going to arrange this thing.
Yeah. Okay. And this what you see here that James just went through. Every one of these items will be covered, is covered in the part model today. So any shapes of bump regions, any number of regions, regions within regions, regions that overlap regions, is all available. Definition of active shapes, seal rings, physical die, stepping distance within a wafer, all of that is physically there. Any type and shape of alignment markers or fiducials that you wish to have is supported. Keep out areas is also supported there. So basically anything that's in this presentation is supported in the part model. And our goal now is to make it a sample of a file that is as complicated as we can possibly make it, and make sure that with the scalability of multi-billion levels of bumps, that the structure is still able to handle it, and it is not a very big file. It's a very small, highly condensed file. So that's the purpose of what the JEDEC group are working on. Okay, so
this is Rudy. So if I interject and just summarize that, so James is going to inform us on the procedure that we would go through to request attending that meeting with you, Michael, because yeah, we would definitely be interested for that scalability. Rudy,
right. So if you want to just come to the meeting,
Yep.
Send me an email with your email address, and I'll add you to the meeting.
I think there are two things we talk about here. One is the performance. I think that you're going to present next time, right? So we're going to do that. I think that's probably more interesting. And this one, I think we can, since you also still continue, because we do have others kind of like a structure we want to add on top of that. So I think this is probably not the final thing that we probably going to be adding things on top of that together with other areas. So I think in line with that, I think what we have at the time when we decide, I think extremely that time is already JEDEC already closer to like approval for public release. They probably can share that. I think then we can probably like run some together, adding on top whatever that we can write to add on top of that. I think maybe that's kind of what I have in mind. But meanwhile, we can Michael, you can provide the questions that you have. When you have that, then we can kind of collect the feedback from the teams, and then we can share that back to you on those kind of like the performance related questions. And then maybe in the next meeting, you can share that, I think, how's the performance and how you conduct the performance. I think that probably will be more interested in this group.
Yeah, absolutely.
So, yeah, so hey, James, Li Hong here. So
Yes,
I just, yeah, sorry, I missed several meetings, but I know Roger, our team is here. So we also have an
Right.
internal discussion. Yeah. So I think that is a very good, the discussion, and also just now the Michael just introduced, I just heard what JEDEC is discussing. So seems they cover, yeah. For example, seems they cover Michael. So in JEDEC discussion, you cover most, more than what they show here, right? So that's what I heard. And so I look at here. So majority of the information being covered, but you said JEDEC they have more coverage on your discussion, right? On this kind of interface, right?
That would be correct. Yeah.
Okay. Yeah. So James, so our goal here, so we try to include as much as possible, right?
Yes, I think we're trying to cover like whatever that is necessary, right? I think I like to do this kind of like the process flow in the like assembly, right? So I think like whatever that need to make sense, I think for to this kind of 3D integration, I think that's the goal that we're trying to cover here, mainly focusing on assembly design, right?
Yeah. Okay. Yeah. So I think the one just to show is very common, but if you talk about kind of a 3D step, yeah, I think we might need to reference what JEDEC is discussing. Yeah.
Sure. Yeah, I think that will come together. I think that's many of these things. I think part of this thing, I think mechanical information are already existing in the part model, right? So I think we talk about sometimes even thermal information. We do have some of that, right, that we use in thermal. In part model there. So but there are others also, I think 3D related. I think which you right to cover. Here we're trying to be more inclusive, right? Beyond part model, I think there's kind of like assembly rules, and we discussed last time. I think you like all those kind of like the even like potential. I think with the a lot of advanced packaging rules as well, right? So different packaging types. and then like different kind of substrate, like in organic, like silicons, like with the routing. We also like going to talk like we like to cover the RDO as well, which is very common in the hybrid packaging, and right and especially the stack up, right? I think TS3, I think that's probably I think like major one in the 3Ds, which is also I think that's one discussion. I think and Tony brought up. I think like he was like meeting I think with a company in Japan. I think which they actually like we met I think at the OCP summit. That they presented this kind of like 3D integration. Called a BBQ. So I think what very interesting. I think it's very focused kind of like the HBM, right? So this kind of like die to die stacking, like memory stack on top of CPU. I think like what they're proposing is like the like traditionally like you stack DRAMs on top of the CPU, right? So I think like this kind of creating I think I show here heat dissipation problems because your heat is going up, right? So it kind of like multiple layer here you're having this problem to kind of release here because like you have to go into heat up all others on top, right? So that what the proposal is change they go in reverse. So they're having like the CPU on top and then they kind of stack from the bottom. So you have a memory kind of stack from the bottom. Then your heat kind of like now easily can be kind of like open up here, can be dissipate a lot easier, and that helps a lot of cooling. And with that, like kind of they can enable this is a hybrid bonding, right? So so it's a bumpless. So pretty much it's just kind of like a hand process, kind of like molding. I think like wafer thinning. I think like going from the bottom. So there are two ways. I think like COW build W on W. I think like probably not going to go into the way details on this. I think like if you're more interested, we may be able. I think like I think next time I think we might invite them or told me more in details, and he's talking more in details with them to share with this. But I think I want to just share with you guys here, with this methodology. I think like the convention compared to this way, I think impedance should significantly drop here, and more important is like the temperature. I think is kind of like can be lower a lot. And then that enables them to be able to stack up more memories that way there. The technology also, I think, including like the very kind of like fine, sorry, here, that's the problem. Very fine pitch TSV. So I think here actually, calculation fine pitch TSV, that enable them to actually like support more higher bandwidth 30 times X and 28 times X lower assistant energy compared to DDR2, DDR5, and then 4 times more higher bandwidth and then 5 times lower compared to the HBM2E, which is coming out soon. I think that proposal, I think is here just trying to we say want to support like 3D stack. I think this is probably what we want to support as well. Right, it just kind of side different process, which potentially I think I have a traction. I think this company also interested. I think looking to using this kind of standard format. I think for the new technology here as well.
Yeah, definitely, James. That is another because this is the DRAM stacking. So people talk about SRAM as you heard, right? So right now there's another trend that they do the DRAM stacking, either underneath the logic die or on the top. So you see here XPU, they basically the DRAM stacking on the top of the logic. And another one, so BBQ, this is very good, so they stacking the DRAM underneath the logic die. So definitely moving forward, you will see more and more they talk about the DRAM stacking instead of they talk about the SRAM. And yeah, we should including this type of a 3D. That's my personal opinion.
Right. I think that's
So
good.
I have some questions,
Yeah.
James. Uh, in terms of my understanding of the relationship between die, interpose, chiplets, and package, dies are on the wafer that gets sent to a company who's going to put them into an interposer, and they have different stack ups of the die going onto that interposer, but ultimately that entire assembly is encapsulated prior to it being sent to the next company. And so that middle company, their process can result in different designs for different products that is unique to that company. The method by which to do the stack up the design of the through-hole silicon vias that connects from one die to the next die, all of that is unique to that middle company. So based on that, what we're currently seeing is hearing about is that the standardization happens between the die/wafer that is generated in company A that needs to get communicated to company B. And then the output of company B that needs to go to company C, that piece as well needs to get standardized. So the communication between the companies is what needs to get standardized in the structure, not what happens inside the middle company. So were ye of the opinion that the interposer, the stack up should be standardized?
Actually, because I'm from, I come up from, if you based on your clarification, criteria. So I think we are doing kind of in the middle, so based on our observation or our positioning, so standardization of interposer is difficult, but because interposer, the definition right now for interposer is also changing. So what we care about the standardization, like you said, absolutely you are right. So we need to pass down the information from the top and from the middle to the end. So yes, so currently the standardization have several levels. So it's happening, majority right now is on the first level, like you said. Okay, so basically we have first the company to go to the second, but whenever they want to put into the silicon interposer, the interposer. So you have the first standardization is regarding the die-to-die communication. That is something the first level, first order of standardization. And talking about the interposer manufacturing and the size and different interposer have not been standardized yet. It's very difficult to standardize, but we have you can see some very standard process how to build interposer, what type of interposer right now being common accepted. So this is, I just want to see from our middle level, our company provide the integration solution, but how we pass down the information to the to the system house, right? So basically currently the model is the system house, they are the owner. So that means they can hire the foundry, the first manufacturing. They can select the middle one like us, but eventually they are the integration for the system. So they have all this information. They have the top, they have the bottom, and they have the bottom what the requirement for system integration. So for us, so so we see right now is a system system house, they will be the final product owner. But that is currently what we see the majority. But like you said, I think that's a very good question. Moving forward, is this the only business model, or is something, maybe diversify? So maybe moving forward in the future. Yeah.
One thing I want to add on. Actually, before that, I think one thing I want to add on top, though, I think I just want to clarify. I think Michael asking, I think the transformation information between these kind of assemblies houses. I think but the other thing also, I think this information format also, I think related to the design, right? It's not just transformation of the format, right? I think when people design this kind of dial DRAMs or CPU, when they want to design this kind of 3D state, they need to know, I think what assembly are capable, right? What technology are capable, and then what kind of rules they need to be adhered to, right? During the design phase, right? So they shouldn't be designing something that come up with, but no one can build it, right? So I think that's what one the rules. I think often we see all this kind of rules coming from this
right.
Kind
so if the rules are being defined by company A and they have to be followed by company B, then yes, all of those rules needs to become part of the digital information that is being passed from company A to company B. But if there is a set of rules in which company B defines for themselves in order to do their activity after they have received the information from company A, and they do something internal and it's entirely internal, then I would suggest that you do not have to standardize that, because it's never going to be transferred to another competitor of B. Another company in the middle is never going to take a standard. They're always going to do something of themselves. So any information that needs to get pushed from one company to the other company is the focal point of the standardization.
Yes, I agree with the statement there. I think I agree. But at the same time, I think I also keep in mind a lot of these kind of rules within a company that also applicable when doing the design. Right? For example, I think how kind of how fine pitch and how density this TSV can be doable within this manufacturer. They need to be known so that when design this kind of the memories, right, and this kind of chip, they know, right, I think when they want to stay in 3D, then they need to know, right, how cross density they can define, right, for the connectivity between those kind of types. So yeah, there are definitely some things specific to manufacturer, but there's also some overlapping, like especially on the design side, they need to know, and also the tools they need to know, that helping the designers to design this thing, even for testing and other purposes.
So you're basically saying that company A will impose some limitations on what company B can do with their product. And so they're not necessarily saying that you have to follow these rules, but you cannot go beyond these rules. Yeah.
Yes,
okay.
Because you have a die to die, between die to die, right? I mean, at the pitch, I mean, how small can you get or how big can you go, right? And then you need to know, so you don't design over those rules.
Yeah.
So that it can be manufacturable. So yeah, I think we both on the side. But definitely there's some other specific, I think more details of chemical things like that. Probably on this specific company, I think we probably need to go into our people that doesn't need to know. But I think there's some higher rules. I think it will be important in the design. Yeah, I think that is kind of want to quickly share. I think which we kind of also cover. I think what we mentioned in initial discussion on 3D style and TSV. But I think this is just different process. So that's something I think and become they are kind of, as Leon also mentioned, I think they more become like DRAMs and other also become more accessible, right? In this kind of 3Ds, standard. So I think that's why we need to also include here. I think in this standard format we're trying to define here. So that's one thing we want to share here, right? And hence, I think based on what we have so far, I think like just going back to that list that we have, we kind of briefly mentioned last time, we have some support and existing rules. I think I probably can share, still kind of extract that information out, probably will share next time, and then like more maybe in more kind of structure, and then I see we can add on top of what existing there here, and see what there's some probably already existing that cover in the part of discussion. There might be some other new thing I think that we can able to add on here. So just right put in that information here. So here so back into this one. So based on our previous discussion, right? So just want to see like a few questions that we have here, right? Is see like if we cover everything here, right? Or is there anything new that we should be including here? And then also secondly, how we going to, this is just very high level components, how we going to expand to the next level, right? I mean, like, is there any priority orders, like any details, more some area we need to more focusing on? And if anyone, I think I have information how we can dive into deeper on these areas. So I think we have some information on this area, right? I think especially I found IntelliSpec around the placement and die-to-die interfaces. There's some 3D, I think as we see just now, I think we do have some information, but I think it's nice to have more information. I think to help to expand, I think the properties that we want to cover here. And then we do also have some, I think part of here, I think from the Intel spec as well. And cover a lot of this kind of assembly, point-to-point, day-to-day, but I think they kind of 3D related, I think that might be covered in here separately. Yeah, I think that's so far, I think that what we hear. I think we talked about last time, I think the radio RF, laser, they kind of a new thing, like wire bonding, I think they kind of probably not a priority at the moment. So I'm probably going to just kind of put a different column here, I think, highlight here. And we talked about we should also to support some of the heating, say heat dissipation, I think which is important, I think to be considered here. And also liquid cooling, I think which is become, I think more and more important. And then also we talk about some wafer source DRC, and we think part of thing we discussed actually, I think earlier, I think related to the performance, that how we support, I think a lot pins, I think part of this thing, and the part model will also have some structure or this supporting. I think this one, I think the just think the micro, I think I can share next time, I think about the performance when you can get those kind of questions that what we providing. I think that will give some insight into it.
I have some additional questions there. And by the way, that email has already gone to you. So I have questions on. So if you wanted to bring that up, given what we just talked about, the information that moves from A to B, and in some cases where, in addition to the die, I provide a whole bunch of requirements that needs to be complied with. Does any of you guys have sample files that you can share with us so that we can see the type of data that is in the files? It's just random sample data, doesn't have to be for a real design, but we'd like to get samples of all of the various design kits that you're thinking about putting into some form of standard. Well, once we get that, then we can start to craft the data architecture to make sure that it can be represented in as condensed a way as an efficient a way as possible. So is there like Li Hong that you were just a few minutes ago, do you have any sample files that you can share with us?
So it means the sample file. So it means the sample file is the design, the packaging design file, or we talk about, you know, related 3D stacking, or it's just like a normal the package with
Well, ultimately, we're going to try and do all of these different systems, because we just don't want to design a structure that matches one type of design rule and not be scalable to match a different type of design rule. So if we could get different samples of data that represents different stages in the die through to interposer through to final package, if we can get different samples of data requirements for each of those, then we can look at the totality of them all and try and architect a data structure that will cover all of that.
So is this the one, you know, the sample means, you know, for example, this is a 2.5D, you know, that what's the smaller die size, what's the packaging size, what's the bump, what's the pitch? Is this the one you talk about? So give one example, like, you know, shearing, scrap line, and those kind of things. Am I right? Or
this is for the purpose of us creating an XML representation to represent a die array that has a very large, super large set of bumps. This is a different query than what I'm just asking now.
I see.
The next once this is for our meeting tomorrow, but beyond that, we're going to move into the beginning of standardizing design rule kits. All the design kits, the ADKs, the process DKs, the material design kits, etc., etc. And so what we're trying to do is to gather a set of sample data so that we can start to look at the totality of all of that and see how we can start to architect a data structure that can scale to handle as many different design kits as possible. So what I'm looking for there is sample files that shows me what type of content is in there.
Okay, so I have, okay. So basically if one example just show what is the content, we got, you know, one type of stack up, for example, because you know, all different applications, they require slightly different, you know, stack up, and they require, you know, different information, the, you know, the stack up information. So what I can see, for example, if, for example, I try to understand, you know, what's kind of information, I'm sorry. So basically, if I can show you one example for stack up, and from there you can see what type of you know, the database structures, informations, you know, those information we need. So you would like to set up those in the standardization contents, am I right?
Yes.
Okay, so yeah, so I can, you know, I can come back, you know, to our internal to see whether, you know, I can share some public information, because this is public, so it's not related, you know, some customers. Okay, that is what I want to, I means here. Then, you know, we can share something to see whether this is a we are looking for.
Okay, perfect.
Yeah. I think this exercise here, I put into kind of the slide here. I think maybe share with everyone. When I think I maybe kind of more like just some numbers. I think I kind of more boundary, right? Like the smallest, right? I think the value probably just not have to be accurate, just kind of estimate, right? I think 5 to 10 years, a few years down the line, some projection, right? May not be that far away because it's so hard to tell. I think maybe a few years down the lines, I think I see what the technology limits there, right? I think what's the maximum possible. I think we'll be going to the big site, or these kind of like the die-to-die areas and site things like that. See where we can go to. I think just some of the projection, right, doesn't be accurate, right? Based on what we have today, maybe based on in the past few years, I think like how much just like the murals, right? How much kind of like these size are shrinking, right? Or increasing, right? So and then like mostly are shrinking, right? The smallest one. So and projection they kind of like reduce 50% every year. I think that maybe 2-3 down the line it's possible to get into right certain sizes, right? And then maybe just put into some size or number here, right? I think just for estimation it doesn't maybe accurate. I think that's kind of exercise here on the purpose. So if anyone have any knowledge information, I think like on the some again this is for kind of like estimation purpose, just for performance analysis, right? So just want to see like in case is that few years is really go according to the projection, going to that everything goes well, going to that kind of like remit. I think and things going to smaller as it should be. I think then like what would be the worst case scenario might come in, right? I think using this format, right? What is the performance look like, right? So I think that's kind of the purpose here. Yeah, I put in the slide here. I think I just put in the chat share with everyone. Everyone, I think please go ahead and feel free to, I think fill out this information so that I think that will help. I think then Justin, Michael, I think to do some like estimate information, and then they can share this information with us. I think and see how's the performance looks like, especially I think using the XML. Is that make sense to everyone? Like anyone has any questions on this?
Ideally, we'd like to get this information back as soon as possible. So I'll drop in my email address there to you, and if you could respond with that information to us sooner rather than later, then we can ensure that the sample file that we generate will be as realistic as possible.
Yeah, I think let's use this one. I think so we can correct it. I think everyone can just kind of like put whatever the number here. I think and then we can kind of correct it on that. I think and respond to it there. Or see what number makes sense there. Or make sure I think there's no maybe duplicate values. I think maybe someone can look into some sizes, and some other people may have a different I think sizes they can put into area. So I can look into some myself. I think Rico maybe can provide some, and then any other people volunteer can provide some information on this. Kendall, do you have any experience on this, or Rudy, Jen, do you guys have any kind of like information, like projection on sizes that you guys might have on top of your mind that you guys can share here?
I'll check with my team and I'll fill this out. So I guess you can add maybe like an extra column on top or something, and then
feel free to put that. I think that's a good idea. I think everyone can put this kind of like name there. I think, and then they can and they can share the data there. So and just put tentative here. I think, and then see like what we can come up with.
Okay.
Okay, I think let's get back to this one. I think does anyone has any kind of like things that we want to add on here, and how we going to expand on the next? We have a lot of information on this thing already, right? I think we might need some additional information. I think we can extract. I think I can kind of extract based on what I think interpret. I think and Jen can probably help here. I think expand on this one. I'm probably going to create another column. I think just tentatively. I think the parameters that we want to or rules, right, that we want to support, right? I think I kind of dive into details in each of these things, and then maybe together with their kind of like units, right? I think that's probably like general kind of like structure, high level. I think I think that may be a good way to start. I think we do have, I think, some good coverage here. I think assembly, I think general rules, right?
Yeah, James, one input
Go
I
ahead.
have is
Yes.
in row 5 you say 3D stack TSV. That's probably the TSV associated with the active die, right? Through the active die. But we may have a 3D HI system where the power delivery or even the IOs are going through mold via to the top stack. So do you want to capture it as part of line item 3, which is it is an in-package structure, right? Through mold via, we can call it as a generic name.
Two more via.
Through mold via, yeah, it's the counterpart of TSV, only not going through the active die.
Oh, I see. I see.
Mold.
Okay.
Through package via, I don't know how we want to generalize it.
Yeah, right. I see what I mean. So this is not within the chip itself, within the die itself, but it's more kind of in between the die.
It's going. Let's imagine a case where you have the top die is small and the bottom die there's a small die sandwiched between two large dies, and those two large dies can talk on the side through using a through mold via.
Right. It's type of TSV also, right? So, but this is only communicating.
It could be
between...
it could be a TSV or through glass via.
Right. That makes sense. Yeah. That is part of you mentioned. I think the active substrate, right? So it could be
It
like
should belong there. Yeah, that's what I think.
Mm-hmm.
So yeah, so this one also, you bring up another one. Actually, here we only talk about 3D. 3D means, currently the definition for 3D is the die-to-die very short links. So either you use through the hybrid bonding, copper to copper, or you through the micro bond. So is this our goal, or you also including kind of 2.5D? For example, here we call the through model via, or or RDL. So RDL can be in molded RDL. That is kind of the organic interposer. And the CD, do you include this? So that's my
we have to. It's a superset of what some people call 5.5D.
yes.
So yeah, that's the end goal, because a lot of DoD exemplars applications would need that kind of structure.
So that means we included, right? Basically, we including 2.5D, 3D, and a 5.5D. So 5.5D is 2.5D plus 3D.
That's right. Yeah.
Yeah. So we including this scope, right?
Yeah, I think we should make sense. I think I personally, I thought we should make sense also to cover all these things.
Yeah,
so
5.5D. Yes. Yeah. So in that case, that makes sense. We talk about the RDL, we talk about through model via, we talk about silicon organic. Okay. Yeah. So assembling, that's very assembling, actually, if you talk about this as a 2-level assembling. So one is you call the 2.5D level, like a chip on interposer. That can be the die to die, the chip on wafer, on wafer, or or module on interposer. Another assembling is on the substrate, and that's 2. Then the design or the assembling rule or the alignment rule are slightly different. So so on the how to say that, it's chip on wafer, yes, and we call chip on substrate, COS.
And then
Yeah.
this one with wafer on wafer, right?
Yeah, also wafer on wafer. Yes. So COS is a chip on substrate. So that is a seal wafer, chip on wafer or wafer on wafer, and
Yeah,
that
and
is
also
the
mix
first
of
level.
them the CoWoS.
Yeah.
And
You don't
just
want
to
to use
complete
the
the picture,
CoWoS.
Lingan,
But-
just to complete the picture, one last thing. One
Uh-huh.
of the examples that we also were working on had with altogether with all of this also had a wire bond.
Oh,
Yeah.
yes. The
Finally,
hybrid
we
bond.
got out of the
About that,
package.
right? Because of 2.5T, right, higher wire bonding is really necessary here.
So
Actually,
I don't know if we want to also have a line item for wire bond. Yeah, you have
we
it.
do have that wire bond, but last time we said about because wire bond may be kind of like phasing out because it's kind of like more for not really for 3D, it's more for 2.5D. But I think you're right; it's still a major technology is going to stay around for a while.
Yeah, because it's a self-contained system, and you're not dealing with a lot of IOs outside of the 3D system, so it may be the cheapest way to take them out. I don't know, but we had an example like that. We have an example.
Yeah, to see that, I think especially in 2.5D, there are a lot like wire bonding. I think they can do kind of like we want some very complex system over. I think like 10,000 of the wire bonding. So
So, hey, James, do you want to
Yeah.
use CoWoS because that is the TSMC trademark? You don't want to use that. We don't want to use that, right? Yeah, I think that is
I
enough.
put in
Yes.
there. Okay,
Yes.
we separate that, but we just kind of like COW plus COS and plus
Yes.
W on W. Yeah. Yeah, it makes sense. I think, but it's the same thing. So we just kind of like plug and play all them together. Yeah, good to share that, I think, information. So, but do you think like this kind of structure makes sense, or we have to reorganize because the kind of overlapping wire bonding could be here, right? How are we going to structure this? Like, do you guys see make sense there? Like,
I think the wire bond have to separate about, what we talk about, the COW, COS, because this is kind of used for the flip chip type of, assembling. But wire bond assembling are different, and the rules different, the methodology different. So if we want to, I know the stack, wire bond also 3D. So I think you should put there. Maybe you just put the 3D wire bond or hybrid wire bond. Yeah. Yes. Assembly. Yeah.
right? I think, I think I
Mhm.
put also wire bond here both places.
Mm-hmm.
The other one mainly for the 2.5D. Oh,
Yeah. Or yeah, they call in wire bond word. They also call that 2.5D 3D.
yeah, I think I kind of had to separate them. They kind maybe you're talking more about just without 3D, just a wire bonding itself, but I think they're kind of applicable in both places, isn't it? Oh,
The stack die, like a wire bond stack die, majority on the RAM, on DRAM, right? For example, right? So that's why they call the 3D wire bond. All this die stack up, 27, 32 die. Then they have a wire bond to connect die to die. I'm talking about that. The
right.
stack die. Yes, that is we should including in our set. It's not a traditional wire bond. That's my understanding, right?
I see. Okay, I see. Okay, not the wire bond from the bond pad on the die to the packaging or something like that.
Yes, yes. That is we talk about the 3D wire bond.
Okay.
Yeah.
This is more kind of wire bond traditional. I think a lot of them is from the dial to the package side packaging.
But is this supposed in the 3D? Well, I saw the ours is talk about the 3D, right? No?
Yeah, we talk about 2D, but we also talk about we want to support a 2.5D as well, right? So I'm just talk about from the 2.5D standpoint, we do have that wire bonding between the dial to dial and also to the package as well.
Yeah. So imagine a 3D of a stack of two dies where you have the large die, and and that has on the perimeter wire bonded package out, and then there's a smaller die stacked on top.
Yes, that's what we talk about, the wire bond stacking
Hmm.
3D, right? So it's not
Yes.
traditional wire bond on the
Got it.
bond tied lead frame, right? That is not that type. We talk about the
Right.
stack, at least have a 2 die, 3 die together, right?
So
Okay.
shall we separate the wire bond between the two with that case, or maybe not? We can include cover wire bonds here with the 3Ds.
I think it either way it works.
Okay, we'll keep that here together then. I think I only see we need to separate that out. And then I think we on top of the times, I think people are dropping off. So I think that's very good progress. I think we first probably getting some information on the type, and then we come back to this one also, like expanding each of the area that we cover. I also will tell everybody based on what Intel spec. I think maybe Jen can help here. I think Jen just stopped. So, but if you can help, I think I also include. Just want to expand this structure, and then we can, once we have this structure, and then we can see like how we're going to put into that standard format there. Maybe also I think Lee Hong and Roger can help some of these like with the 3D like bump to bump rules called chip on wafer and wafer on wafer and chip on systems as well.
Yeah, we will work internally, yeah, provide some input.
Okay, yeah, also look into this as well, and then when we cover this other area, maybe we'll come and continue talking in the next area, and then maybe you can revisit again on the wire bonding and others, like the copper pillar and micro pumps and others then in the next discussion, and the hybrid bonding. I think hybrid bonding cover here too, right? So some of these like micro pumps cover here too actually, so maybe you can run some together. Yeah. Anything else from anyone? I think we're on top. Right. Meanwhile, I also get the recording from previous meetings, so I can share with Jen and Yuri Hong, you guys. I will put that in the meeting minutes so you guys can access in the previous meeting. Including like the spec presented by Justin earlier. I think I just for the information.
Yeah, thank you. Hey, James, can you share, the paper they published, the BBQ? The BBQ.
Yeah, sure. I already said that. I put in the.
Oh,
I
you
will
shared
put.
that.
Yeah, I put in the chat, but I will put in the meeting minutes as well.
Okay, thank you.
Yeah. All right. I think that's all then. If nothing else, I think we'll probably will continue discussion in 2 weeks. Anything else from you? Yeah. If not, yeah, we will cover in 2 weeks. Thank you very much.
2 weeks is Thanksgiving.
Oh yeah, sure. We'll see then. Yeah, maybe like after the Thanksgiving. It's end of the year. I think a lot of holidays are coming. Yeah,
So the next one then will be what, 7th of December, or will you bring?
Yes, yes. I think will be
Okay.
right a month from now then. Yeah, unless something like urgent come up, I think we can push it up. But for now, tentatively, yeah, we'll have Thanksgiving. We'll meet in a month. All right. Yeah. Thanks everyone.
Thank you.
Thank you.
Happy Thanksgiving.
Oh yeah, happy Thanksgiving everyone.
Yeah.
All right. Yeah. Bye bye.
Okay. Bye.